Welcome to your lesson on the sine and cosine ratios. The sine and cosine ratios are extremely similar to the tangent ratio, except sine A is opposite over hypotenuse and cos A is adjacent over hypotenuse. So at this point, we now know so, ka, toa. Let's jump into an example. In triangle DEF, identify the side opposite of angle D and the side adjacent. So if we look here, the side opposite is 4, and the side adjacent is here, and the side hypotenuse is here. So sine D is equal to opposite over adjacent, which gives us opposite, we said was 4.0, and adjacent was, oh, that's not right at all. I meant to say this is opposite over hypotenuse. Our hypotenuse being 8.5. This says to the nearest hundredth. Should be to 4 decimal places, which I know is not hundredth. So 4 divided by 8.5, 4 decimal places is 0.4706. So 10,000th. Our cos D is equal to adjacent over hypotenuse, which gives us 7.5 over 8.5. 7.5 divided by 8.5 gives us 0.8824. And this just wants us to find it to the nearest hundredth, so we're not trying to find our degree. Sine B, sine A, cos B to the nearest hundredth. So if we look at our angle A and what it's equal to, we don't know, but if we identify from angle A our side opposite is equal to 10, our adjacent is equal to 24, and our side hypotenuse is equal to 26. So sine A is equal to opposite over hypotenuse, which is 10 over 26. To 10 to 4 decimal places, we get 0.3846. Our cos A, which is adjacent over hypotenuse, gives us 24 over 26. To 4 decimal places is 0.9231. If I look at this now, cos B, angle B, we don't know what it equals to, and I gotta make this line a little smaller. Our opposite is 24. Our hypotenuse is 26. And our adjacent is 10. So sine B is equal to opposite over hypotenuse, which is 24 over 26 is equal to 0.9231. And you should notice that these answers are the same. So we can infer that cos B should equal 0.3846 without even doing the work. And that's because of how the ratios work. We're not changing anything, we're just changing the angle measure that we're taking them of. Now we're going to use this knowledge and we're going to find the measure of angle B and angle D to the nearest degree. So if we look at angle B, let's make our identifier. Angle B says what we're looking for. We can also call this X, I think I'd called it in class. Our side adjacent is 4.6. Our side opposite, we don't know. And our side hypotenuse, which is across from the right angle, always is 8.7. Given adjacent hypotenuse, we're going to use cos. So 4.6 over 8.7. 4.6 divided by 8.7 is something we could do, or step 1 first is we can do our cos inverse, which will leave us with angle B is equal to cos inverse of 4.6 divided by 8.7. Okay, so cos inverse bracket of 4.6 divided by 8.7, close the bracket. Making sure calculators isn't degrees, the nearest degree is 58 degrees. Now with angle D, we can use that all triangles equal 180 rule. So we would have 90 minus from 180 minus 58, all in degrees, which gives us 32 degrees. Our angle of elevation is the angle between the horizontal through eye level and a line of sight to the point above eye level. We're going to use this in a lab, so it's good to know. An observer is sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water and 430 meters from the observer. Remember, we said that most cases in here we can assume safely is a right triangle. Some people might say that 430 should be down here, but if we know that the plane is up here and over here, it makes sense that this should be 430 meters. Shortest distance, sorry, the longest distance when we cut through a thing. So we need to determine the angle of elevation to the nearest degree. So this angle, theta, is what we're looking for. So we're going to call that x. Our hypotenuse is equal to 430, and the opposite is equal to 300. So the ratio we're going to use given opposite and hypotenuse is we're going to use sine theta is equal to 430. Is equal to 300 over 430. And then we are going to take the cos inverse of the sine inverse of both sides, knowing that that is the opposite operator here, to give us that angle theta is equal to sine inverse of 300 divided by 430. So we go shift sign, second sign, 300 divided by 430, close the bracket, hit equals, making sure our calculator's in degrees, and we get 44 degrees. Okay, the question should be on Google Classroom. If you have any questions, please let me know.